Let us solve homework 2.3. So question 1 asks, well, let's read the question together. It says, in the following problems, find the general solution of the given differential equation. So it basically says solve the ODE, which is y prime or dy over dx is equal to, well, here in this case, we have 5 times y. Okay, so to solve this problem, first of all, remember that here in differential equation, we have some steps. We need to take those steps. We need to identify the classification, the membership that this differential equation belongs to. So step 1, what is the classification? What classification? So is it separable? Is it linear? So far, we talked about these 2 classifications. Later on, we add more, and then we're going to expand the idea, having more and different types of differential equation. And after you figure out which classification, which membership this differential equation belongs to, you can apply that method. So in step 2, apply the method. Okay, very good. Let's check to see if this guy is separable or not. Sometimes separable has much more easier and direct solution, the method to solve this integration of both sides. Let's check that. Let us check if y prime equals to 5y is separable or not. Very good. So remember that we're going to have all y's on one side, all x's on the other side. So let's do a quick algebra. Let's use a different color. Algebra. So what are we going to do? We're going to multiply everything by dx and divide everything by dy. Multiply by dx, divide by just y. So here you get dy divided by y equals to 5. Dx is a separable. Of course, it's separable. So let us apply the method. Yes. Take the integral. You need to take the integral of both sides. So now we have to do the calculus part. Calculus. Take the integral. So the integral of dy divided by y equals to the integral 5 dx. Well, on the left-hand side, we have ln of absolute value of y equals to 5 times x plus constant of integration. Now, again, we go back to algebra and try to write y in terms of x. Try to write it, for example, explicitly. Algebra. Okay. Based on the definition of ln, we get absolute value of y equals to e to power 5x plus c. Again, let us just call this c sub 1. Eventually, we're going to change the letter. And absolute value of y is equal to e to 5x plus c. So we can separate these exponents. We get absolute value of y equals to e to 5x and e to c sub 1. And y is equal to plus minus e c sub 1 e to 5x. Guys, here we have another constant in differential equation. We don't want to have all of these complicated, messy representation for the constant. So we just call it c sub 2, c, k, any variable that you like. So it says, hey, the general solution is c e to 5x. This is the general solution for this differential equation. It was separable, so we could easily solve this. General solution. You might say, well, what if I want to check to see if this guy is linear? Well, Remember that when you have a differential equation, you might be able to apply different methods solving that differential equation. Out of curiosity, let us check if it is linear or not. Remember that to have a linear ODE, we need to have, well, a sub 1 x y prime, the first order linear ODE, a sub 0 x y equals to g of x. If it's in this form, then we have a linear ODE and we know how to apply the method. We need to write it in standard form, divide everything by a sub 1, and then find the integrating factor, multiply everything by integrating factor, and continue. So I'm going to use a different color. Is a linear. Take a look at this. We're trying to compare this differential equation with the general form, general pattern. Here we get, let's see, y prime equals to 5y. So first of all, do the subtraction and bring 5y to the other side. You get minus 5y equals to 0. By comparison, here you see you have y prime and the coefficient is just 1. So far, so good. Here you get plus minus 5. So a sub 0 is a constant, negative 5 times y equals to g of x is equal to 0. So it means that we have a homogeneous linear differential equation. This is a homogeneous first order ODE. Okay, so the answer is yes. As we solve this differential equation using separable method, we can solve this differential equation using linear method as well. So we have to follow some steps. For a linear one, you have to write it in standard form. So 1 standard form. It means that we have to have coefficient of y prime be 1. You're lucky in this case. The coefficient is just 1. We're not worried about this. So this is checked. Step 2, find the integrating factor. What's the integrating factor? The way that we define the integrating factor is e to power integral of px dx. And what is px? Px is the coefficient of your y. The coefficient of y is negative 5. So here we have the integrating factor e to power negative 5 dx, which is equal to e to negative 5x. This is our integrating factor. 3, multiply everything, every term by the integrating factor. Very well. So let us do that here. We get y prime e to negative 5x times y prime minus 5 e to negative 5x times y equals to 0 times the integrating factor, which is again 0. Well, in the last step, 4 and then 5. In 4, the linear ODE becomes the derivative of e to integral of px dx integrating factor times y. And on the right hand side, you have your, for example, function qx, or if it's 0, you just copy down 0. In this case, since we have 0, we're just going to write down 0. And the last one is take the integral. Very well. So on the left-hand side, we get dx of the integrating factor e to negative 5x times y. And on the right-hand side, you have 0. Now take the integral. when you're taking the integral, you get the integral of dx, which is the opposite of each other, the opposite operations, they cancel out each other. You're left with e to negative 5x y equals to the integral of c of 0 is just a constant like c. Okay, so what is y? Y is equal to c e to 5x. We found the general solution for this differential equation using two methods, separable and linear. As you can see, you have the exact same general solution. They must be the same.